Hey, welcome back everyone. So today we are going to start our new video which is on color detection and real-time tracking. So topics we are going to cover is HSV color model, color masking, webcam color detection, noise filtering, real-time object tracking, mini project. Okay, so what is HSV color model? Before we start detecting colors, we need to understand why we use the HSV color model instead of RGB or BGR. OpenCV reads images in the BGR format, where every pixel contains blue, green, and red values. Although this is perfect for displaying images, it isn't ideal for detecting colors. Imagine holding a red ball under sunlight and then moving it into a dark room. In the BGR color model, all three values change significantly because brightness affects the color values. This makes reliable color detection difficult. To solve this problem, OpenCV uses the HSV color model. Now, what is HSV? So HSV stands for, here H means hue, S means saturation, and V means value. So hue, which actually represents the actual color, and saturation, which actually represents how pure the color is, and the value represents the brightness. Now, why HSV? Because lighting mainly changes the value channel. The hue remains almost constant, so detecting colors becomes much more easier. Okay, so now let's go to our terminal and see how we can convert our webcam to HSV. Okay, so now first we will starting by convert our webcam to HSV. So to do this, as usual, we'll first import the CP2. Now then, we'll capture the webcam. So as from the previous video, we have already learned this. And now, while true, red frame equals to cap red. If not red, then gray. We have already know this part. How does it work? So I don't have to explain it again. Now, okay, so from this portion of this code, we already know what is happening here. So our laptop's the primary camera, which is connected to the laptop. For me, it is my webcam. So it will be open and it will capture what is in front of this camera. And now at the red comma frame, it will read one frame. And now we'll write the code to convert the HSV. Okay, so to convert it to HSV, we'll write here HSV equals to cv2 dot cvt color, then frame cv2 dot bgr to HSV. So our camera will convert from BGR to HSV. Okay, now after that we will just show, as we already know how to write this, cv2 I'm show HSV, and we can also add here the original one, which is cv2 I'm show original frame, and then if break, and we can write it here. Okay, if I run this code, you can see and now you can see that this is the original photo, original video, and this is converted HSV channel. So this is how you can convert it. And okay, so this is how we can convert this. Now let's move. So if you have noticed that the HSV image looks strange, that's because it isn't designed for humans to view directly. Instead, it stores color information in a way that makes computer vision tasks like color detection much easier. Okay, so now let's move to our next topic, which is color masking. Okay, so suppose in case of color masking, so what is it actually? So suppose we only want to detect the red objects. So we simply tell OpenCV that you keep the red and remove everything else. So this process is called color masking. So the output is a binary image. So white will be the selected color and black will be everything else. So now write the code here. So I will write here import CV2 and then import numpy and then capture video. Then okay, so now we will create a range. What are we calling the red color? So the lower red equals to, okay, so this is the color combination of for the lowest range for the red, and this is the upper red. Anything else from anything else which is not in this range of color will be black. So while true, we'll write here the red frame equals to cap red. If not red, then it will break. Then convert it to HSV scale as we have learned it before. And now we'll write here masking. So write mask equals to CV2 dot inrange HSV lower upper, and then CV2 mask and original frame, and here as usual we do that. So okay, now if I run this code, okay, so in right now in my frame there is nothing red. So here you can see everything looks black. But if I bring anything red here, suppose I have this scope, you can see now it's capturing as red, and here you can see this side here is capturing as red. But if I show this side, it won't detect anything. But now it is detecting the red color. So if I have any other object like this, it's gonna also detect this. Though my camera quality isn't very good as is a laptop webcam, but if you have a very good quality camera, you can detect much more clear image. Okay. So now we'll move our next topic, which is now okay, so okay, now we will do another little bit of change here, that we'll display only the red object instead of showing a mask. So let's show only the detected object. So how we can do that is, here we'll do a simple change, which is we'll make here the result equals to bitwise frame by frame, and we'll here use it and we'll remove this one. Okay, so now it will detect instead of just showing the mask. So and now as you can see, if I bring this, you can see it is showing the color, not white, right? Now it is showing the color. You can see that. Before doing this, we had only white. Now it's just detecting this color. So using this method, we can detect any colors from any video or anything. So if you can see this like that. Okay, now here actually, so instead of displaying a black and white mask, here CV2 bitwise AND operation, which uses the masks to keep only the selected color from the original frame. Every other pixel is removed, making the detected object easy to see. Now if we want to see any blue color, what we can do here, we will just change this range. So we'll write here 100, 150, only 50, and here keep it as it is, just 140. So now it will detect the blue colors. Now if I just write this here, you can see that, as you can see that my jersey color here, some blues are detecting by this. Now if I have this, you can see it's detecting now blue. So any color what you want to detect, it can detect very nicely. Okay, like this. One thing I want to just tell you right now, that we have to sometimes remove noise. So sometimes you will notice small white dots appearing in the mask. So these are caused by lighting variations, reflections, or camera noise. To remove them, we'll use morphological operations. The most common technique is opening, and which removes tiny white noise while preserving the larger objects. So for this, we simply add these lines here. I'm just showing you, because after that I will going to do a simple project, then you will clear how actually we use these things. And okay, so this thing, when we use this thing here, which actually here the kernel in P1's P, P in it, we actually creates a 5x5 kernel used to examine neighboring pixels, and CV2, the disparate morphology, which performs the opening, is an erosion followed by dilation, removing isolated white pixels without significantly affecting the main object. Even after color masking, the webcam may detect tiny unwanted white noise. The morphological opening removes these small noise areas while keeping the main object intact. Okay, so now let's move to our final project, which is the real-time color tracking. Now we will use here everything what we have learned, and we'll also apply the noise removing technique here. So let's start coding. So start with import CV2 and then import numpy, and as we have used it like this, and then for right now, so now we will like to use here the blue one, so the lower blue, which is this, and we can use the upper blue like this. And if we use our kernel here, while true, then red frame goes to cap red, if not red then break, and then we can write here also HSV, we'll convert it, then we'll use the masking. Now we will remove noise from that mask image, so use this, which will help to remove the noises. And after that, we'll find the contour. As from the previous video, you know what contour is and what it actually does, so I'm not explaining it here. Okay, so what we'll do here, we'll write here if CV2, then we'll create a boundary around the our detected object. Now we'll find the center. So M equals to CV2 moments contour. Now if I will explain it now. And then okay, we'll write here text and then CV2 mask to be tracking CV2 base, and finally cap release and install Windows. Okay, so let's explain some part of this code, which is important to know. That as this thing you already understand that we have here made the range for color detection, and after that what we have here is we have created a kernel here, and what it actually does is this creates a 5x5 matrix filled with ones. So it is used for morphological operations, such as we have already told you that small noise removing. And after that we have created here loop. You already know what we have done here. Then we have converted to HSV. Then we did mask, and after that what we did here is remove noise. So here this removes small white dots caused by camera noise or reflections while keeping the main object. And after that we did contour here. So this function actually searches the binary mask for the outlines of the white objects. We have already discussed this in previous video. And contours contain the boundary points, ignores the hierarchy because we don't need it here. And also now that we have a clean binary image, OpenCV finds the boundary of every white object. Each boundary is stored as a contour. After that, what we do here, we have put it a loop, which is a for contour in contour. So there may be more than one blue object. So the process needs to be continuously run for individually, and it will, after that you can see we have put it here, the CV2 contour area is greater than 500. So it will actually ignores the very small colors or very small pixels. And after that we'll draw a boundary box. So for this we have written here the CV2 rectangle frame like this way. And after that we have drawn the rectangle, and we have to find the image moments. To do that we have inserted here the moments contour. So actually image moments are mathematical values calculated from the contours. They help us to compute properties such as area, centroid, and orientation. And for center we use here CX, this which is actually M10 divided by M00 and M01 divided by M00, where actually M00 is a proportional to the contour area, and M10 and M01 which actually the weighted sum of the x and xy coordinate, weighted sum of the x and y coordinates. So moments are actually the mathematical measurements of the contour. Using these values we can calculate the exact center of the detected object. Now after that what we have done here, that okay, so what we actually did here, y not equals to 0, because if the contour area is 0, dividing by 0 it causes an error. So this checks ensure the calculation is safe. And after that we have calculated the center, and lastly we have draw the center, and here is a put text that we have displayed the label like it's a blue object, so we have put it here. So now one thing is here, after that, okay, so here I think I should have written something here like CV to POTX frame. And after that what we have done here, okay, so what I should done here, I should put a level here instead of writing dx and dy. So I will change it right now. So after frame, I'd like to write here not this. Instead, I'll write here blue object. Okay, now it's okay. And then I also instead of this, what we'll do here, I'll write here and do x comma y minus 10, and then CV2 from have a simplex. Okay, these things are good, and you can just increase the okay, simply just as it is. So make it 0, and so the color will be looking good. Make it 2, and I think after that everything is almost completed. And let's see, run this project, is it good or not? Let's see. Okay, so if I bring anything blue, so it's actually detecting. And if I have something good like this, it is detecting the blue object. Even without anything AI or machine learning, you can just simply detect object using OpenCV. You can see that here it's actually detecting the object very nicely. Even though I don't have a very good quality camera in my webcam, but it's detecting very good. So any color, anything, it can detect nicely. See, even if I rotate it, it can detect this without even distorting this image. Okay, so this was the video, and I hope it helped you, and this is for today. Thank you.